Hi students, let's look at this question here, which was taken from the year 2020 NYJC CT Common Test 2 paper on question 10. Let's go do this professionally. So the motion of particle is described by this differential equation. So this is the governing equation for the acceleration and also the speed here. X is the displacement of the particle in meters, and by using substitution, x equals to u to t, show that differential equation may be reduced to this, where d square u dt square, where a is a constant to be determined. Okay, so I'm just going to do the first part first. It seems like a huge question here. Just copy down the equation. Copying down the equation should be quite okay. This part here, just going to be dx square dt square minus 4 dx dt plus 4x equals to e2t, right? Then what we're going to do is actually just going to put this is the substitution that we're using. U equals to e to the power 2t. Then just differentiate with respect to t. dx dt. This will be u. Product rule is u a constant. A is a constant, so u is not. So u e to t dot with 2 plus, keep the one on the right, differentiate on the left, so du dt. See that? So once this is done, of course we can't just substitute it in now, because we're gonna just put this 2t here. This is 2u plus du dt. Okay, dx dt here. Now once we are done with this, we need the second derivative here. So what? We only have got the first derivative when we use this substitution here. So what I'll suggest is we just going to differentiate this again. So d square, so this is d square x dt square. This will be keep the one on the right and differentiate on the right with respect to t. So maybe I just write this down. Differentiate with respect to t to x. Differentiate with respect to x as well. So this case here, once done, this is 2 du dt, okay, plus d square u dt square. So differentiate this. Okay, let me just color code it for you. This is your product rule. So u, this is your v. So you can make u1 v1. So this is u v1 dv dt, okay, plus v 2e2t. Okay, so this case here, this will be v1 du1 dt. Okay, so this is what you do. There you go. Once done, I'm going to just replace everything in. But before that, I'm not too sure whether I could just I'm going to just factorize the e2t out. dt square plus 4u plus 2 du dt. There will be 4 as well. So e2t 4 du dt. We put this as e2t. Then this is 4u plus 4 du dt plus 4d square u dt square. Okay, because this is by substitution, what I'm going to do is actually just going to sub 1 and 2 into the original equation. So this original sub 1 and 2 into the original equation here. Okay, so let's do it. This will be this case here would be into 3. So I'm gonna get you can get this one, dx square. So this is e2t 4u plus 4 du dt plus 4d square u dt square, and after which we get minus 4 dx dt minus 4 dx dt is this one, e2t, bracket it is 2u plus du dt. Okay, so once done, we get plus 4x and then after which we get equals to E2t. So x as well, we need to replace x as well, so this x needs to be substituted in as well. So this 4 and 4. Okay, so x will be u e2t. So get rid of all the x. The whole idea is to get rid of all the x. Okay, so this would just be u e2t equals to e2t. Okay, there you go. Maybe I should just move everything. Okay, great. Once done, what we're gonna do is just cancel all the 2t out. So this 2t, cancel this, cancel this, cancel this out. Remember, when you cancel all this, will just be 1 left. What we get is actually just 4u plus 4 du dt plus 4d square u dt square minus 8u minus 4 du dt minus 2 plus 4u equals to 1. Okay, then we can just cancel the things out. This happens to cancel each other. 4u here, 4u is 8 minus 8, and this will cancel out each other. And once we're done, we get d square u dt square 4 equals to 1. So d square u dt square equals to 1/4. A is a constant to be determined. I think A is 1/4. Let me check if I have any mistakes there. I have a careless mistake here. So I just realized that my plus became a 4 eventually. It was quite bad. So this is plus. This became a plus. Okay, great. This is okay, so A is just 1. So let's look at the subsequent one. Hence, find the displacement of particle of t if the particle moves from the initial point of t x equals to 1. So it means when t is 0, the initial point is 1 with a velocity of dx dt, which is 1. The displacement at time t. So in other words, you need to find x in terms of a function of t. Okay, so that's what we need. So first thing, I'm going to write down all the boundary condition. X equals to 0, sorry, t equals to 0, t equals to 0, the displacement start off was 1, and dx dt, the velocity was 1, right? So t0, yeah, x0, there you go. Now once this is done, we are going to write down the we're going to solve this differential equation by using what they asked us to show, because this is in a separable form. Anyway, this is second derivative, so to get that, this is 1 over dt, and this will just be t plus c, after which u will just be integrating t plus c dt, and that will be t squared over 2 plus ct plus d. Okay, so now we have u. We know that u is because u, the substitution of u, x equals to u e2t. So in other words, u equals to x over 2t. So this general form here, we have already solved it. We know that x over 2t is equals to half t squared plus ct plus d. What we need to do now is to just go and hunt for all the different constants, right? The c and the d. Okay, so how we do that? We do that by hunt it down. So okay, when t is 0, we know that x is 1. So in other words, it's 0. So in other words, this equation here, if you sub it in 0, 1, 0, 0, 0, what we get is actually 1 equals to E0, 0 plus 0 plus D. Then you know that D is equals to 1. Now we need to find C. C would be when we could just find C from the second derivative here. So this case here, this is U equals to half T squared plus CT plus D. I mean the first derivative. Why do I find it here? Because I need to find a way to actually use dxdt. I don't have dxdt to use, right? So I'm just going to use this boundary condition here, and the way to use it is to use du dt, sorry, here du dt here. Okay, so how do we find it? So the first thing is, obviously when t equals 0, x equals to 1, we need to find u. So 1 equals to u is 0, and we know that u is equals to 1 then. Okay, now we know that du dt is equals to t plus c. So we need to find out what's the c, right? To find the c, we're going to find the first derivative just now, which is here. See that? So dx dt is equals to 2t. So we just sub all the values into this one here. So substitute it this. This will be, let me just put this up. Okay. This over here, sub into 1. Is sub into 1. What you get is dx dt is 1 equals to 1. This is e equals 0. 2u, u is 1. And plus du dt. Not sure what's du dt. That is what we want to find. Okay. So this is it. So du dt here is what we want. So is du dt is actually equals to -1. So sub it in here. So you will get -1 equals to 0 plus c. So c is actually -1. Okay. So from here, what we get is hence x is equals to e to t half t squared minus t plus 1. That's how you do this question here proficiently. Yeah, if you have what do they want us to do in any form? No. Okay, so we can just leave it like that. Let's look at the subsequent one. After some time, the particle is returned to its initial position and set into a new motion along x-axis. The motion of the particle is described by this differential equation. It's a new motion, so it's different now, where v is the velocity of the particle in meters per second at the time t after it starts on its new motion. T after, so this is another t. So now the question now is, if you return back, so the first half of the journey would have, let me see. The first half of the journey, you go back. So this is another set of t1, then this is t2. Okay, so this t2 will start from t2 is 0 here. Then this is t1, 0 here. Just remember that it resets because it says it starts from the new motion. If the particle is at rest just before it begins the new motion, find an expression of t for t in terms of v. So this will be a piecewise function, I believe. Because now v meters per second t. Find out t in terms of v. Okay. No, sorry, not piecewise. This is just they just want v, so they do not really want the v is just the next motion. So I'm going to use calculate that. So this case here, what we get there is actually dv dt is actually just 2e minus v. So this is separable form. This is actually 2 over ev, so this is ev1. So this is separable, ev dv equals to 1 dt. Okay, so once done, this will be ev equals to t plus c. There you go. Great. So what we need now is the particle is motion. The motion of the particle is described by this differential equation. We return to its initial position. Initial position is x equals to 1, right? And t equals to 0. T is after, so t equals to starts from the new motion. So when t is 0, x is 1. So t is 0, x equals to 1. What is v? Particle is at rest before it begins a new motion. V is the velocity. Okay, so V is 0. It's at rest, right? V is 0. So x equals 1, t 0. So V is also 0. So this will give us E0 equals to 0 plus C. So C is equals to 1. So EV is equals to t plus 1. And then we just ln both sides. We will get V equals to ln t plus 1. Okay. Same thing, I did a careless mistake. I missed out a 2 there. So this is a 2 here. There's a 2 here. There's a 2 here. There's a 2 here. Just 2t here. Yeah, there you go. So there's the V. V is the yeah. So we've done this. Now let's look at the last one. So for last one, show that 2x equals to 3 plus EV v minus 1, where x is the horizontal displacement of the particle in meters. What we need now is to just know that this is a velocity of, this is a new velocity. So the velocity v is, this is very physicky, dxdt. I think it will benefit the students in the physics. So this is what you do. We need to solve this part here. So dxdt is equals to ln 2t plus 1. That's what we need to solve, right? So show that 2x equals to 3ex, where x is the horizontal displacement of the particle motion. Yeah, that's about it. Velocity is dxdt. So I think just integrate this, ln 2t plus 1 dt. This is by parts, we all know that. So by parts, using u as ln 2t plus 1. Choose this as your u. This is your dvdt. So dvdt will just be 1. And du dx, du dt will just be 2 over 2t plus 1. V will just be t. Okay. There you go. So this is x equals to t ln 2t plus 1 minus 2t over 2t plus 1 dt. So how to solve this? Do long division, of course. So this case here, you can do a long division, or you can just use a juggling method here. So I'm going to use plus 1 minus 1. That will be x equals to t ln 2t plus 1 minus of 1 over, okay, just put this as 1 minus 1 over 2t plus 1 dt. Alright, that's how you do this part here. Then what we get is x equals to t ln 2t plus 1 minus t plus ln 2t plus 1 over 2 plus a constant. I'm not sure. Okay, use e. Alright. You asked us to show, right? So we are getting there. We just need to make x a subject. Is x the subject? We need what? Or in terms of v. Goodness, v is what we need. Let's look at that. So we know that when t is 0, x is actually 1. Correct? So when t is 0, x equals to actually 1, right? Because that's the initial position, right? Initial starting point is x equals to 1. That will be 1 equals to 0 minus 0 plus 0 plus e. E is equals to 1. Okay? E is 1. So this will be x equals to t ln 2t plus 1 minus t plus half ln 2t plus 1 plus 1. Then what we need is, because we need it in terms of v, so we're just going to sub v in. This is v, this is v, this is v as well. That's about it. We need it as v. So this case here, we get x equals to t v minus t plus half v plus 1. Great. What do I need? I need to express x in terms of v. My goodness, why is the v there? Let me see. Because there's no t here. Okay, there's no t in this expression here. So upon closer inspection, even my t here needs to be removed. Okay. So I think it's pretty okay once you understand that you need to find the t. So we can just say t is actually ev minus 1 over 2. So I'm just going to replace everything out. So this case here, what I'll get is, okay, maybe I should just shrink this down a little bit more. Okay, here. So x equals to EV minus 1 over 2. So there you go. I needed everything to be in terms of okay, maybe I should just factorize this out. T is EV. I needed everything in terms of V, so that's a problem. So this is actually x equals to T V minus 1 plus half V plus 1. So T is actually EV minus 1 over 2. Okay, then this is V minus 1 plus half V plus 1. Alright, am I right? Multiply by 2. Multiply by 2 throughout. Wow. Seems like it. I mean, this is more of a manipulation question than anything else. So I'll get this as yeah, that's how I show it. Okay. So that's how I do this question proficiently. If you have any questions or comments, please do let me know, and I will see you in the next horrible questions.